The sun is the source of all man's energy. Around it, the Earth moves in perpetual orbit. Around the Earth, a smaller moon is rotating. Light from the sun casts shadows behind the Earth and moon. When the Earth's shadow falls on the moon's surface, we see some or all of the moon blotted out. This is an eclipse of the moon. This film shows the moon entering the Earth's shadow, or umbra. It takes 2 hours for the moon to pass through the shadow area. During this time, it travels 5,000 miles. The eclipse comes to an end when the moon passes out of shadow. Here we can actually see the shape of the Earth's shadow on the moon. For what does this provide evidence? As the moon travels round the Earth once in every lunar month, you might expect there to be an eclipse of the moon every month. This is not so. Imagine a straight line extending through the sun and Earth, and beyond the Earth to the other side. If the moon passed directly through this line on its journey around the Earth, we would see the monthly eclipses of both the sun and the moon. But the moon does not travel this way. Instead, the moon's orbit places it either above or below the line on most of its revolutions. Unless the 3 bodies are in position on the line, the shadows of both Earth and moon fall off into space, and no eclipses occur. Here are pictures of another kind of eclipse, an eclipse of the sun. Let us consider further the shadows cast by Earth and moon. These consist of 2 distinct regions, an inner cone of dense shadow called the umbra, and a surrounding region of partial shadow called the penumbra. Sometimes we can see an eclipse when standing in a part of the world in partial shadow or penumbra only. Then we see a partial eclipse of the sun. However, if we are in a part of the world in total shadow or umbra, we see a total eclipse. The sun is actually 400 times larger than the moon. During an eclipse, however, the moon is large enough to blot out the sun. Why is this? Here is the moon's umbra traveling across the Earth. It sweeps out an area no more than 60 miles wide at 1,500 miles per hour. Only within this band is a total eclipse seen, and for 7 minutes only, to an observer on the ground. A plane flying with the eclipse shadow can extend observations by a few minutes. To make observations of a total eclipse of the sun, scientists travel to remote corners of the world in order to be in the narrow 60-mile band traced out by the umbra. Let us watch a total eclipse of the sun with a scientist. The clouds darken, and a false semi-twilight announces the approach of totality. Through the telescope, totality itself. Let us look at this again, stopping the camera at certain points. Just before totality, we see a thin crescent of the sun's chromosphere. This is a gaseous atmosphere around the sun. The spots at the opposite edge are called prominences. Here are the prominences shown in detail with a special lens. They are really tremendously hot portions of the chromosphere, thrown out in long, flame-like tongues with explosive violence. They can travel outwards as far as 250,000 miles. The eclipse proceeds to totality. The sun is completely covered by the moon. Now we see that there is another gaseous layer, even around the chromosphere. This is the corona, and shows itself as a faint pearly glow. The gases of the corona are thin. They reflect and scatter light to produce a halo effect. Here the corona is partially obscured by clouds on the Earth's surface. Now, however, the clouds pass. The corona extends up to 500,000 miles. Its study is a main object of eclipse expeditions. In it, scientists can study gases at high temperatures at 1 million degrees. Occasionally, the corona reaches near to the Earth. Here it may heat the upper atmosphere, affect the Earth's magnetism, and even our weather. The aurora borealis, or northern lights, is a phenomenon seen in northern latitudes. It is caused by radiation from the corona. All observations on the corona during an eclipse must be quick. Within 2 minutes, the mass is on, and the glare of the full light from the sun makes it impossible to see the faint coronal glow. Short though it is, the brief passage of this shadow across the Earth allows scientists to obtain new information and make many measurements. But information can only be built up slowly. In one man's lifetime, all the total eclipses which occur do not add up to 2 hours of time. The sun is our most important heavenly neighbor. Its study during eclipses is extremely important to us. But our sun is only one single star among millions in a firmament whose size defeats imagination. Many of these stars are so far away that their light travels for thousands of years before it reaches us. Eclipses teach us much about our sun and our solar system. How much shall we be able to discover about the universe in which we live?